Good day, my name is Bosompen Papa Kwame, and in this video, I'll be presenting and design the construction of an Arduino Mega 2560 as shown here on my screen. This presentation will cover stages, three main stages of the design process. First, I will explain the schematic design and how the major components are interconnected. Secondly, I will demonstrate the PCB layouts, including the component placement and routing. Finally, I will show the 3D view of the completed PCB design. The main purpose of this design is to recreate an Arduino Mega 2560 development as a custom PCB while maintaining the major functionalities of the original board. Okay, the schematic construction. The main microcontroller used in this design is the Atmega 2560. It serves as the central processing unit of the board and controls the input and output operation of the Arduino. Yeah, this is the main microcontroller board. The board also contains a USB to serial communication section, which is here as highlighted. Yeah, and another important part of the schematic is the clock circuit. Yeah, the Atmega requires a clock signal to execute the instruction. The reset circuit is also included. The reset functions allow the microcontroller to restart its program execution when required. Hope I'm making myself clear here. Okay. After completing the schematic, I perform the necessary electrical checks. Yeah, I perform the necessary electrical checks and then assign suitable footprints to the components. This allows the schematic to be transferred into PCB layout. Yeah, as you can see here, there was only one error. Okay. And then okay, wait, it's taking a while. Okay, this is the first point, as you can see here. Okay, I'm closing. I'm going back to the PCB layout. Okay, here's the PCB layout. After transferring the schematic to the PCB editor, I arrange the components on the board according to the functions and connections. Okay, this is the PCB layout of the schematic I'm doing. Yeah, I'm updating it. Yeah, this is the main microcontroller processor. Yeah, with the power chart, the USB, and the main power source. Yeah, the switch. Okay, hope I'm making myself clear here. Now, I'm on to the 3D. Finally, I will show the 3D view of the design, the Arduino Mega 2560 PCB. Yeah, here's the 3D view. From this view, you can verify the physical placement of the orientation of the components on the board. Okay, the 3D preview is useful because it helps us identify the possible physical problems such as components interfering with each other, components extending beyond the boundaries of the PCB. And finally, based on the schematic, PCB layout and 3D model, the design provides a complete workflow from electrical design to physical PCB implementation. In conclusion, this project demonstrates the complete process of an Arduino Mega 2560 board using keycard. The process started with the schematic design where the electrical connections and the major functional sections were created. The schematic was the was converted into a PCB layout where the components were placed and the connections were routed. Finally, the 3D viewer, as you can see here, was used to inspect the physical appearance and component arrangements of a completed board. Excuse me. This project has helped me understand the complete PCB design workflow from schematic capture to PCB layout and 3D visualization.